to learn how to quickly solve this definite integral in your next exam, but only if you stick around and learn this important trick that saves you time. So grab a mug in the description below, enter the number Dojo, and let's get started. For this problem here, notice that we have this constant k, and it appears in two different places, and we want to figure out what value of k, or values, allows this integral from the interval of 0 to 1 over 4k to equal pi. Now, you might be able to do this in your head already, but for those that can't, totally fine. By inspection, we can use what's called a u-substitution method here. So you will let the u equal 4kx. That way, when you take the derivative of both sides, you will find that du equals 4k dx. But because we have this 4k here in front of dx, and it doesn't appear there in the original problem, we got to solve for dx and isolate it by dividing both sides of the equation by 4k. And this allows us then to substitute in du over 4k for that dx term above. But hold on a second, we're not done. Many of you make this mistake, and I cover it in the video you can see above, but whenever you're doing a u substitution for a definite integral, you can no longer use your old limits of integration because they were dealing with x as your domain. Now we're dealing with u, and so we need to transform those values into the domain for u. But we know that u equals 4kx, right? So this is pretty simple. All you do is you plug in your lower limit value of integration for x into this equation, and then you repeat it for the upper. So starting with the lower limit of integration, x equals 0, we're going to find that u is this really nice value that's also 0. And then when you plug in this upper limit, which is 1 over 4k, you're also going to get a really nice value of u, which turns out to be 1. So then rewriting the integral now in terms of u, what's really cool here is we've actually eliminated the k variable from the limits of integration, which makes this simpler. And then by inspection here, the next thing you might see already is that, you know what, we've got this 1 over 4k constant that we can bring outside of the integral. And I'm going to do just that. That way sine of u du is by itself, and we know by inspection that that's a really easy integral to solve. And now you can maybe see it already, but there is this really important trick here that you don't want to miss. And before I forget to mention it, if you're finding value in my videos and you want to keep seeing new content, be sure to ninja kick that subscribe button and turn on that bell notification so you don't miss future videos. And only for you serious students out there, I also offer $1 a month memberships, so you get a bunch of extra perks like watching my videos early. So then what I want to do next here is I'm going to be able to look at this and say, you know what? By inspection, we know the integral of sine of u du is going to be negative cosine of u. And all we need to do now is we need to evaluate this from 0 to 1. And before I forget to mention it, do you see also a possible problem here? You have this constant 1 over 4k, right? What if k is 0? Is division by 0 allowed? So hold on to that thought for a second. Let's just move forward, not dealing with that yet. By inspection, with the fundamental theorem of calculus, we know the way that we can evaluate this from 0 to 1 is you plug in the value of 1, the upper limit for cosine first, and then you minus it by evaluating it with the lower limit of 0. And the other thing I did here is I actually pulled the negative that was in front of the cosine of u out, all in one step, so that that negative is in front of this 1 over 4k. Now, by inspection, we know that cosine of 0 is a really nice number. It's a 1. For cosine of 1, I'm going to leave it the way it is because it approximates to a decimal, and I want to make sure my final answer is precise. So all we got to do now is solve for k, and so I'm going to multiply both sides by negative 4k, just simple algebra at this point, right? And so you're going to have cosine of 1 minus 1 remaining on the left, and then when I divide both sides by negative 4 pi, I'm going to find this as one of the solutions for k. And the question for you now, and you tell me in the comments below, is remember I mentioned above the possibility of dividing by 0 if k were to be a value of 0. You tell me, can k be 0 as a possible solution for this problem? Why or why not?